In this video, we have the integral of the square root of 36 minus x squared. Now, usually when you have a radical like this, got a difference in squares, it's going to be a trig substitution most of the time. If you have a difference and you have a constant that can be written as a square or is a square minus a variable square, this could be x or u, then it's going to be the sine substitution. If you have it the other way around, x squared, say minus the number, in this case 36, you have the secant substitution. If it's a sum, you've got the tangent substitution. Well, sometimes the radical will appear in the denominator. In this case, it's in the numerator. So the objective then is to write this integral, rewrite it in terms of the variable theta. So we don't want an x. Instead of dx, we want a d theta. So like I said, it's going to be a sine substitution. So you can start off by saying it's going to be x equal to, this is the a here, a squared. So a would be 6. So it would be x is equal to secant sine theta. Or you can rewrite it also as sine theta is equal to x over 6. And use the fact that the sine of an angle is the opposite. If you have a right triangle, it's the opposite over the hypotenuse. So in this way here, here's my triangle. Sine of theta is opposite x over the hypotenuse 6, x over 6. And then from that you can form the other side using the Pythagorean theorem. So the sides of this right triangle, this is a right triangle here, got x, square root of 36 minus x squared, and the hypotenuse is 6. This side squared plus this side squared should give me the hypotenuse square, which is 36. So starting off this way then, take the derivative here, get dx. Derivative of sine is cosine. I get d theta here. So dx is equal to 6, cosine theta d theta. So we've got something to replace the dx in terms of theta. And for this one here, for the radicand here, got 36 minus, and then x is 6 sine theta. So if I put in 6 sine theta there, that'll give me a 36 sine squared theta. And I can factor out the 36 from there. And then the square root of 36 would be 6. That'd be a 6 here. And that would leave me here with 1 minus sine squared theta. After factoring out the 36 and taking the square root. But 1 minus sine squared theta is the same thing as cosine. Using your basic identities, cosine squared theta. But then you take the square root of that, and you get a positive cosine. Again, we're assuming that the angle that we're using is acute. So if the angle is acute, all the trig functions have a positive value. Square root will be positive then. So that's how we get this 6 here. Plug it in 36, or I'm sorry, 6, in for x. And this part here gives me 36 sine squared, factor out the 36, take the square root, and like I said, the 1 minus sine squared can be replaced by cosine squared. That'll have a square root of a positive cosine theta, because we're dealing with an acute angle here. So I can start then, say this will be the integral then. This will be 6 cosine theta, and the dx is 6 cosine theta, and then I have d theta. So this will be the integral then. 6 times 6 is 36, so I'll put this outside since it's a constant. And then cosine times cosine gives me cosine squared of theta, and this will be d theta. Now this was just a plain old cosine theta to the first. We can easily integrate that because of the square here. We've got to use an identity from trig. So still be 36 here, and this will be the integral of, and there's an identity for cosine squared. It tells me that cosine squared of the angle theta is equal to 1 plus cosine of 2 theta, and that's over 2. Now we can integrate. We have a 2 here, so let's just divide the 2 into the 36. That'll give me 18. And that'll leave me with 1 plus cosine of 2 theta, d theta. And we're going to integrate here. Integral 1 with respect to theta. Still got the 18 out in front here. Integral of 1 with respect to theta is theta. The integral of cosine 2 theta is sine of 2 theta. Using the chain rule in reverse here, the derivative of 2 theta is 2. So I'm going to divide this by 2 for this to come out. So check it here. The derivative of sine of 2 theta is cosine. But then chain rule, derivative of 2 theta is 2 over 2 here. Gives me the cosine. This is plus the constant of integration. Now sine of 2 theta, we can simplify that. Again, using a trig identity, this will be 2 sine theta, cosine theta. And the 2's here will cancel. 2 here and a 2 here. So let me continue up here. So from here, I'm going up here. Still got the 18 there. And then this theta here, we want it in terms of x. Now we have to go to the original variable. So here's sine theta is equal to x over 6. So if I take the sine inverse of both sides here, sine inverse of sine theta will give me just theta. So theta will equal to sine inverse of x over 6. So I can replace the theta by sine inverse. You could also use arctangent, or arcsine I should say. So we have arcsine then of x over 6. It's going to be plus, and then we have sine theta. So sine theta was the, right here, x over 6. And that's multiplied by cosine theta. That was the adjacent side over the hypotenuse. So the adjacent side from the triangle was the square root of 36 minus x squared. That's over the 6. That was the hypotenuse. Adjacent side, square root of 36 minus x squared over the hypotenuse is 6 plus the constant of integration. So now we just multiply by the 18 here. So it's going to be 18 multiplies the sine inverse. So let me just remove the parentheses here and put the 18 here. And then notice here we have the 6 here and a 6 here. That's 36. And then we're multiplying that by 18 here. So it's going to be 18 over 36 times the x. That'll give me a 1/2. So that means that this will reduce down to a 2 here. Got a 6 and a 6 here, 36, and then we're multiplying by 18. That reduces to 18 over 36, or 1/2. Then you got the x there. And this is what we wind up with this one. 18 times inverse sine of x over 6 plus x over 2 times the square root of 36 minus x squared plus your constant of integration. And then I remind you here that there is another formula that you can use whenever you have something in this format here. And we talked about that, or I went over that in a video comparing the two integrals here. So let me, here's your triangle just used to finish the problem. We looked at these two integrals in another video. Both of these can be derived using a trig substitution. Same substitution we used for this problem. But if you're allowed the use of this formula, notice on the first one the radical is in the denominator, and there's the answer. If you can write it in that form, maybe in some cases you might have to use a u substitution to get it in that form. But once you have it in that form, it's sine inverse of the x over the constant, that is the square root of that constant, a squared. So that goes to a plus the constant of integration. Now, in this problem, we have it in this form. So you use this formula. So notice it's a squared. Now in our case, the a squared was 36 divided by 2 gave us the 18. And then it was sine inverse of x over a. So we had the x, and this was 36, or 6 squared. So this was x over 6, and got this answer here. And then it was plus x over 2. Okay, x over 2. There you have it. And then the radical, the square root of, in our case, it was 36 minus x squared. But if you have it in this form, where the radical is in the numerator, then you can use this formula, unless your instructor tells you can't. And then the first formula, if you have it in this form, again, you can go directly to the answer. Most instructors will let you use the first formula. Just make sure you check which ones you're allowed to use. So that's the end of the video. Thanks for watching. We'll see you next time.